Hello everyone, welcome back to Discrete Mathematics with Adila Krishnadi here. In the previous video I mentioned that we will talk about matching, but before that let's talk about let's formalize our general procedure to determine whether a simple graph is bipartite. So here is a theorem. A simple graph, undirected graph I should say, is bipartite if and only if each of its nodes can be assigned one of two colors so that no two adjacent nodes share the same color. So this is actually our idea when we solve the our previous exercise. So we start with a node and we assign it red, and then assign its neighbors green, and then assign the next neighbors red, and then you take turns alternately. So does this hold in general? Well, this theorem says yes, right? So let's prove this theorem. Yeah. So let's start with the only if direction. Yeah. So a simple graph is bipartite only if each of its nodes can be assigned one of two colors so that no two adjacent nodes share the same color. Now, so suppose G is bipartite. Now, if G is bipartite, then of course phi will be equal to phi1 union phi2, such that phi1 and phi2 intersection of phi1 and phi2 is empty, and of course an HE is in E if and only if the endpoint of E, one is in one endpoint of E is in phi1, and sorry, let me just make it more clear here, such that one endpoint of E, say U1, is in phi1, and the other endpoint, which is say U2, is in phi2. Yeah, so U1 is in phi1 and U2 is in phi2. Yeah. Now, if this is the case, then well, we could color them, right? So coloring, say red and green, yeah, can be achieved this way. So color all U in phi1 with red, and all phi all W in phi2 with green. Yeah, so because of course G is bipartite, no two adjacent nodes are in the same set phi1 or v2, and thus uh, no two adjacent nodes are in the same set, and those two adjacent nodes, no two adjacent nodes will share the same color. So we've shown that if G is bipartite, then we could uh, assign colors to the nodes so that no two adjacent nodes share the same color. So now, what about the other direction? So the if direction. So suppose G is a graph such that uh, nodes can be assigned one of two colors, say red and green, yeah, such that well, no two adjacent nodes share the same color. Well, does so now what we want to show is whether G is actually bipartite. So is G bipartite? Well, the answer is of course yes, but let's show this. The answer is yes. Well, G is bipartite, or I should say, let's define the partition. All right. So let V1 to be the set of nodes U such that the color of U, so color of U is red, and V2 be the set of U in node U such that the color of U is green. Yeah. So obviously by our assumption then V1 is disjoint with V2, right? Because no two adjacent nodes, because every node is assigned one color, right? Not two colors. So yeah, so because each node U in V only has one color. Moreover, well, obviously V1 union V2 is V, right? Yeah, because all nodes are colored. Now what remains is to show that the bipartition condition, right? So bipartite condition. So let E be an edge such that ST of E is U1 and U2. Now because no two adjacent nodes share the same color, yeah, then U1, so the color of U1 must be different than the color of U2. That means U1 is in V1 and U2 is in V2, yeah, or vice versa, right? Yeah, so that means you have this, so therefore E does not connect two nodes in V1 or V2. So G is a bipartite graph. So with this, we can determine whether a graph is bipartite by simply attempting to assign the nodes with two colors so that no two adjacent nodes share the same color. So with that, let me stop here, because the next one is going to be matching, and we shall continue with matching in the next video.